right, so let's discuss related rates, T40. So the thing with related rates is that they're going to be word problems, and it's figuring out the rate of change of a particular variable. And so let's just kind of start, and we'll pick it apart here. A pebble is dropped into a pond, causing ripples in concentric circles. The radius r of the outer ripple is increasing at a constant rate of 1 foot per second. When the radius is 4 feet, what is the rate of change of the area of the circle? Okay, so there's some things that are true for every related rate problem. For one, they give you there's a given constant rate. And notice it's talking about the radius of the circle. Now, the first step in related rates is you draw a picture. Now, in this one, the picture doesn't do a whole lot for you, but there's some things I want to say. That doesn't look like a very good circle, does it? There are things I'm going to say, sorry, I'm picky, that have to do with ones that the drawing will be more helpful, so I will do that. And that's this. When you label things on your picture, you do not label any numbers unless that number is a constant. So when I label that radius of r, notice I don't put that it's 4 feet, okay, because that's in one particular moment. So really the only picture I have is this circle. I'm going to write my given. My given information is the constant rate. Now think about a rate. This is the change in the radius over time. So anytime they're talking about a rate, it's going to be whatever variable, d, in this case radius, so I'm going to use r, and then on the bottom is dt, the change in the radius over the change in time. And then I get 1 foot per second. Now I always ask myself, is the radius increasing or decreasing? Well, it says that the radius is increasing. So if your variable is increasing, that means dr dt, the rate, is going to be positive. Sometimes you have to put in a negative if your variable was decreasing. So we'll deal with that a little bit later. So there's my given. Dr dt is 1 foot per second. The next thing I do is I write a find when statement. That helps me to know where I'm going, what I have, etc. When the radius is 4 feet, so that's going to be our when, what is the rate of change of the area? So again, the rate of change, I don't say what's the area, I said rate of change of the area. So I'm going to find, you're looking for a rate, dA dt when r equals 4 feet. So that's what my find when statement is. After I get that find when statement, I look for what's called the relating equation. What equation relates the variables that I'm talking about? I mean, look at my picture. I'm talking about area, I'm talking about radius of a circle. So what is my relating equation? You think, well, the area of a circle. So the area of the circle, and yes, that's one that you are expected to know in your head, is A equals pi r squared. Notice I do not fill in 4 for r. You do not put numbers in for your variables until you've taken the derivative, and that's going to be my next step. I am going to take the derivative with respect to time. These are related rates. I'm doing the rate at which you drive to school, you're in miles per hour. The rate at which you walk or whatever is feet per second. So anytime you're looking for a rate of change of the area, you're going to take the derivative with respect to time. So the derivative of A is going to be dA dt. Now my variable over here is r. I'm going to do the power rule, power to the front, decrease the power by 1, but again I have to do the implicit part, the chain rule, so I would have dr dt. This is where I fill in. I get dA dt, that's what I'm looking for, so that's the variable I don't know. I have 2 pi. I can fill in r was 4. If after I've taken the derivative, that's when I can put in my numbers, and notice that I would get dA dt is 8 pi. Now I'm going to write two different ways, and if I didn't run out of room, I would like this kind of down here at the bottom. So this is my answer. They're very picky in how they write the answer. Notice that in my work I didn't do this, but I write it like this. Oh, yeah, the radius is 1. I write it this way because it's the same thing. It's like if you say f of x is 4x, this is just a dumb example. If I say find f prime at 1 and I get 4, I can't just say f prime of x equals 4. Because f prime of x is not always 4, it just happens to be 4 at 1. So you denote that you're evaluating the derivative at that particular value that way. Well, it's kind of the same thing in this related rates, is that, again, with your work, I'm okay with you not doing that, but at your very last line, what the grader is going to look at, you need to make a notation that dA dt is dependent upon the radius. It's not always 8 pi, but it happens to be at that particular instant. So you're saying you're evaluating dA dt at r equals 4. Now, what else I've left out is the units. Okay, the units, I have to have that on there because units are introduced. Well, I'm doing the rate of change of the area. What would be the units for area in this problem? Well, the radius was in feet, so the units for area would be feet squared over the radius of the rate of time was seconds, so my dA dt at r equals 4 is 8 pi feet squared per second. Now, I'll be honest, I think, and I know you're thinking, I'm not going to do that because that's more writing. But I tell you, and to be honest with you, I like writing a sentence. Rather than doing this, because I tend to forget, I literally recopy. AP loves it when you just kind of restate the question. And so look at that last sentence of the question and look at my answer. I'm going to say when the radius is 4 feet, the rate of change, or the area, is increasing at a rate of 8 pi feet squared per second. I like the sentence, so I would go straight from here to here. And I don't even write that. I just think that's good. I think that, especially when we get into the negatives and they ask you to interpret, that helps you with the interpretation and understanding what that means. So I will be honest with you, I have it on my homework that you do that sentence. So I would like for you to practice that. Okay, let's try the next one. Air is being let out of the spherical balloon at a rate of, find the rate of change of the radius at the instant when the radius is 2 inches. So again, I have a balloon. I don't have, my picture is not great. I'm not going to draw three-dimensionally. I still have a circle with a radius. And so let's do the given rate. Air is being let out of the spherical balloon at a rate of. Now, you might say, well, what letter is that? Is that dA dt, dR dt, dV dt, what? The units are your best friend. Units are your best friend because what would measure inches cubed? What would be measured in inches cubed? You'd say, well, volume. So that means dV dt, the given rate, is 4.5 inches cubed per minute. Now remember, I always ask myself, is the volume of that balloon increasing or decreasing? Well, if air is being let out of the balloon, the balloon is, it's shrinking. So the volume is decreasing. If your variable is decreasing, that means the rate is negative, and you have to put that in. You have to do that interpretation. So there's my given. Now I got to do my find when statement. Find the rate of change of the radius. Find dr dt when r equals 2 inches. Okay. What's my next step? Write the relating equation. Well, golly gee willikers, looky there. They gave that to you. You do not have to remember every volume formula. Anything with a circle, area, you should know that. Circumference, that formula you should know. Anything with a rectangular box, like volume of a box or area of a square, that you should know. Any other shape, they're actually going to give it to you. So my relating equation was actually handed to me. Thank you very much. And what do I do after that? What I do after that is I take the derivative with respect to time. So dv dt, power to the front, so this 3 goes to the front. I always reduce as I go, because notice I'm not using a calculator here. So 12 over 3, of course that's 4, pi r squared dr dt. Now I plug in, there's a bell. Now I plug in my numbers. I have negative 4.5 is equal to 4 pi. Now is when I can put in my 2 dr dt. Now I'm looking for dr dt, and I want to be very clear. What's so hard about this lesson is that I have seen this on calculator, and I've seen it on non-calculator, I've seen it on free response, and I've seen it on multiple choice. So when I'm teaching it, I kind of have to cover all of my bases. So notice I'm not using a calculator. So let's just talk what I would get for my answer. dr dt, I think I'll go ahead and do this. This is pretty an easy one. 2 squared is 4. 4 times 4 is 16. I think we're all in agreement that I could write it this way. In reality, you could actually leave it written like this. They don't care that you simplify, so some people would say to do that. I'm pretty confident I did that in my head correctly, so I'm going to leave it that way. But there again, what if, again, free response, you can leave it. You don't have to simplify anything. But I'm telling you on multiple choice, which this could be on multiple choice, they probably wouldn't leave 4.5. They probably wouldn't leave the decimal in the top. So think of 4.5 as being 9 over 2. So I could write the answer, because with multiple choice, you got to find the answer that's there, so you got to kind of keep going until you find the answer that they have listed. Now let me write my answer if it were on free response. I would say when the radius is 2 inches, the radius is decreasing at a rate of 9 over 32 pi. Now let me get my units. What would be the units of radius? Well, in this problem it's inches. My time was minute. So there's my answer. And I know you're like, just tell me one thing, but there's so many different things that they could be doing, and I want to be very clear. Could someone also say, notice I said decreasing at a rate of a positive. You could also say when the radius is 2 inches, the radius is changing at a rate of negative 9 over 32 pi inches per minute. That would also be acceptable. Now, I like to interpret the positive or negative because in some AP problems, I've seen it where they ask you to like interpret what that means and they want you to write that. So I think it helps you think about what you're really saying. So I like to do it this way. I interpret the positive and negative for increasing, decreasing, but notice I do not do decreasing at a negative rate. It's kind of like a double negative. Okay, so decreasing at a negative rate would actually mean increasing. So I don't care which one you do. If you're writing it, I will accept both. But you have to do one of them. Okay, but if it's multiple choice and they ask for dr dt, what did you get? You got a negative. So dr dt is negative. How you interpret that, you could write it a couple different ways. So that is what you're going to be doing tonight. Notice that on the next slide, it kind of gives you your steps. And also it tells you some formulas that you'll be given, formulas that you are expected to know, and so you'll have that there for your reference. Okay? Good luck. Please practice, write your sentences, and make sure that you are going through your steps. I might add a couple stars here. Don't draw, only put numbers on the picture that are constant. That's a good one. Express the given information. You might want to put watch for negatives. Because remember, you have to put those in. Yes. Okay. So good luck with that. Practice, because y'all, they get harder. You got to practice tonight because they get much, much harder. Let me give you a little tip on one of your questions. It's the last one. If you were doing a product, you have to do the product rule. So on number 5, my hint to you is you need to think product rule. So I'm gonna say this. I'm not gonna write the actual formula, but if I were doing x to the squared y or something, if I was taking the derivative with respect to t, I would do first times the derivative of the second, so dy dt, plus the second times the derivative of the first, 2x dx dt. So make sure on number 5, now number 5 is not that, the formula is not that hard, so it's I didn't want to do the exact one, but my hint to you is on number 5, you need to do the product rule. All right, good luck. Try to do tonight's homework, A40, with no calculator. Okay, let's just pretend that all these were on a non-calculator part. When we get to the more difficult ones, we'll get a calculator on there, but today, no calculator. All right, peace out.